Geology department.
Hi, everybody. Welcome to this meeting, and I'm glad you've been able to make it and join us here in the evening. I'm Rick Bell. I'm a professor of geology, geological sciences, and I'm also the chair of the department. And geosciences is a broader term that encompasses a lot of different fields are involved with studying the Earth, and we'll talk about them later. But this is the one of the primary places you would go if you're interested in actually working and solving environmental problems on this Earth. So I'm going to talk to you about the need for geoscientists, what careers are available to you, how you get prepared for those, and a bit about our degree and our curriculum as well. So, people are brought to geology, as I said, mostly because they're interested in addressing problems for people and for their love of outdoors. And different people play different roles in addressing environmental issues and global challenges. It's the scientists who are the ones that discover the problems and define them, characterizing them with their research. It's the engineers and the scientists that then figure out, what do we got to do about this? How can we implement a solution to this problem, whether it's air or water pollution, or it's a lack of resources, or some sort of hazard? Then there are the advocates. And the advocates are the people that go on out there and try to influence policy and politics and human behavior and get people on board to do the hard things that we need to do to address these issues. And then there's the educators. And the educators are the teachers or the people that give lectures and talks or make films. And those are the ones that actually are inspiring and educating people, and students in particularly, to play the responsible roles that are needed as they move on through with their lives. So these issues lead to a global need for earth and environmental scientists. And these are a special kind of scientists that have a much more broad and interdisciplinary training than most other sciences provide them. In physics and chemistry and biology, in many ways, you work in laboratories, you have lots of controlled experiments. But in the earth sciences, we have to deal with the real world as we find it. And therefore, we have to develop the skills and able to develop a scientific understanding of how to work with it and how to address it. So if you major in geology or earth science, you will, in the course of your classes, develop the applied and interdisciplinary skills and knowledge that's needed to address these world problems in environmental issues and in resource management. And you will be trained well enough that if you are a decent student, you'll be able to land good jobs and start a career right out of school with your bachelor's degree. In fact, there's such a need that the U.S. Bureau of Labor Statistics says that in 6 years, there's going to be a deficit of almost 120,000 geoscience positions in the United States, just when our need is going to be the greatest. So that means that even though there aren't anywhere near as many jobs in geosciences as there are in like the health science industry, the number of jobs per students graduating is actually much, much larger for geosciences than in biology. So geoscientists study the earth and the environment. And just to clarify a few things, environmental problems are the problems that occur to the physical earth. That's damage to the earth's surface, its water, its soil, its oceans, its atmospheres. And much of this damage or disturbance is done by human beings, although not always. This is the realm of the geoscientist. Then there are ecological problems. And this is the realm of the biologists. And this is disruption of the biological systems, of the ecology, of the life on the earth. And that disruption usually follows from number one, which is damage to the water or soil or atmosphere in ways that disrupt the life systems. Then there are geologic hazards. Geologic hazards are naturally occurring features that, when they occur in the wrong place or people are in the wrong place relative to them, they can turn into natural disasters that cause great deals of property and even human life loss. And these are things like earthquakes and landslides and floods and volcanic eruptions and coastal or cliff erosion and falling, or sea level rise, sinkholes, climate change, extreme storms. These are all the geologic hazards that are addressed, studied, and then dealt with, and people get advice from as scientific experts of geoscientists. And then we have resources problems. Human society requires energy and materials in order to have a decently high standard of living. And most of the world doesn't have anywhere near the standard of living that we have in the United States, and they greatly desire to have the energy and resources that we do. So there's a tremendous demand for resources for nearly almost everything we make or use in this planet. And so that is also the realm of the geoscientist, is how to find and manage those resources. So here's a graphic, a block diagram showing some of those things we were just talking about. The geoscientists have to deal with how we live alongside natural hazards and where we put our houses and our buildings and our schools and how we build them. Geoscientists work to find the raw materials that we need for society. And that's for everything from the metals we use to the energy that we produce, whether it's geothermal or hydroelectric or oil and gas. We are the ones that have to figure out where that energy is concentrated and how we can deal with it and get it. We have to learn how to deal with waste, both where we put it on purpose and how we can seal it off in many ways from harming our atmosphere and our oceans, and also how we prevent areas from becoming polluted in the first place or clean up areas that have become polluted. We study the coasts. Excuse me, I have a phone call coming in that I hope turns off here shortly. And also, this is really important for things like soil erosion and clean water and things like that. So this is all the realm of the geoscientists. So geoscientists, geo is earth, science of course is science, is just another name for the broad earth sciences. And this involves all kinds of aspects depending on your interest for both careers and in what just is an exciting thing to you. So this is geologists. This is hydrologists that work with water, both on the surface of the earth and underground. This is oceanographers, or earth scientists, or geoscientists, environmental scientists. Seismologists that work with earthquakes and earthquake hazards. Paleontologists that work with fossils to understand the history of life on Earth. Naturalists that may go on out and lead hikes and teach in the parks and in the national forests, or work to preserve natural spaces. City planners are often geoscientists as well, because we have to deal with the actual capabilities of the land that we want to build in with respect to flood or liquefaction, earthquake as such. And very importantly, geologists, geoscientists can become teachers. And for my perspective, they make some of the best science teachers because they have such an interdisciplinary perspective for teaching any aspects, whether it's chemistry or physics or geology or other kinds of environmental science. So geoscientists, because of this diversity of background, because of the ability that you develop to solve problems that are not easy to solve, ones where the answers are not all in front of you because you're in a lab where you're controlling absolutely everything, where you got to figure out something that you did not observe, just like a detective does. Geoscientists go on to do all kinds of things. So here's just a couple examples here. There's probably many of you know Lucy Jones, who talks to us often about earthquakes, but geoscientists have become the Secretary of State of the United States and the head of the Joint Chiefs of Staff, Colin Powell. Geoscientists have become the Premier of China. Geoscientists have become the head of science operations in NASA, or the last and only scientist, PhD scientists who have ever walked on the moon. Geoscientists are the ones that made the first maps of the sea floor, like Marie Tharp up here in the corner. So there are many, many things that you can do with a geoscience degree that's beyond doing the geoscience, because the innate problem-solving ability in addressing problems where everything's not in front of you and much is unknown is a skill that you develop as a geologist or geoscientist. So we have, as I said, a growing need for geoscientists. And that is because we have a lot of problems in front of us that society needs to address. We need to address problems of water, pollution, energy, other resources, natural hazards, even national security, because when it comes down to it, a lot of issues like wars between countries has to do with resources, land, energy, things like that. And where we can build safe homes and buildings, roads, dams, things like that is all. This is all contributing to the need for highly trained geoscientists. And as I said, the US government predicts we're going to have way too few just in the next few years. So geoscientists, students and professionals study the earth. They study the rivers, they study the rocks, they go out to the mountains, they study ancient lakes to understand the past climate of the earth. We study the ocean. We work along the coastline and the beaches. We go out to sea, where we use remotely operated devices and submarines to study the sea floor. We look at records and evidence of past earthquakes and landslides underwater, and we study the wetlands all along the coast. Geoscience study weather and climate and all the effects of those changing in weather or climates, shrinking glaciers, change in precipitation, floods, storms, mud flows, debris flows, glaciers, all those kinds of things are part of the realm of the geoscientist. We study the natural hazards and how to build and live safely among them, and how to live in a way that is resilient and does not cause devastating loss when the inevitable hazards occur, like wildfires, landslides, earthquakes, etc. All of these pictures here are from Southern California, just to show you that even the place that we live is a place that is potentially dangerous, and people need our help in order to figure out how to live safely. So geoscientists save lives by helping people understand where it is safe, where it is not safe, where if you are in a hazard, you can position your building or your house or your dam in a way, or build it in a way that will make it less likely to come to harm and for people to come to harm. Geoscientists use all kinds of very, very high-tech equipment, from global positioning systems, electron microscopes, to virtually every kind of a chemistry device that you might find in a lab as we study the earth, remote sensing, all kinds of things. And we get out in the field. We get out in the field in order to understand how the history of the earth has led to the distribution of natural resources in a very unique way. So you just cannot drill a well anywhere and find oil. You cannot dig anywhere and find iron ore. You cannot just go anywhere and hope to find the lithium that you need for batteries. They are located in the places they are located and concentrated to a degree that they actually make economic sense for us to find them only because of the unique geologic history of the Earth, its tectonics, its evolution, its climate change. And so understanding that and applying that helps us find these critical resources. Because of all this, geoscience careers are pretty well paying. Shown here again from US government statistics, the median earning, that's the 50% point, 50% less, usually earlier in your career, 50% greater, usually later in your career, is $92,000 a year. That's a pretty good salary. Starting salaries right out of a degree, bachelor's degree, is usually around 50,000. It's a little bit higher than that in California, and that 92,000 is higher than the median for all physical scientists, which would be involving chemistry and physics and such like that, and way higher than for all occupations which don't have the training and the value that a geoscience degree has. The U.S. Bureau of Labor Statistics also says that there is a growing need, that the employment for geoscientists is projected to grow 6% in the next 8 to 10 years and 12% in California. That's faster than for most other applications on average. And this is due to that need for environmental protection, energy development, and responsible land and resource management that is only getting more important as we go into the future. So there are different paths you can go on in earth science careers or geoscience careers, and you're not necessarily locked into one, but these are the different directions people go. So there's the corporate path. This is going to work for companies that work in an aspect of geoscience. This is environmental, engineering, oil, mining, different kinds of resources, where you're working in business, providing a service, or providing materials. Then there's the nonprofit agencies. These are the agencies that are advocating or doing studies and reports and making recommendations to governments on environmental issues, planning issues, and educational issues. Then there's the government, and this is at all levels, from city and county to state and federal. The things like the Environmental Protection Agency, Caltrans, in California, CalGEM, which is the California Geologic Energy Management Group, the State Lands Commission, the United States, and the California Geological Survey, the National Park Service. These are all the kinds of career paths that you can go if you're working for the government in a geoscience career. Then you can go into secondary education, teaching at high school, middle school, or high school levels. Just this last week, I was teaching a course with one of the professors in science education to physics instructors at the high school level, showing them how to get the earth sciences into their physics classes, how to understand the concepts better, and how to link them with their physics so that they can teach them better. Then you can go a more academic route, which will require additional training, a master's degree or a PhD degree, and that's becoming an academic like I am, and that is teaching at a community college or university level, where you might be engaged in research as well as teaching college students of your level, from the introductory to the specific and professional. So how do you become a geoscientist? Well, first you got to decide to do it. So you got to declare a major in geology or earth science. Second, you need to do the background. Geology, as I told you, is interdisciplinary. So I think we are the only major in the college that requires students to take classes in the other fields. So you got to take your calculus in math. You got to take your chemistry classes. You got to take your physics classes. You definitely want to take the intro geology class. We call it Planet Earth here, and the lab that's associated with it, because that's where you're going to convince yourself for sure, hey, I really like this. This seems to be a good thing for me. But at the same time, you got to start, sharpening your mind and connecting your love with your intellect, and get outdoors into nature. Look around you a lot. Critically observe your environments. Go, why is that there? Why does this look this way? Why do they think it was okay to build a nuclear power plant here when I see these landslides? Travel as much as you can. Well, that's maybe not easy to do right now with the pandemic and the coronavirus, but this is going to end sometime and then we can get back to it. And then come in and get your degree. We welcome you. Come to our department or call us, and we'll tell you all about the opportunities and what we're doing here in the department here at CSULB. Another thing is, I gotta tell you, is geology students love what they do. Geology professors love what they do. Professionals that are working in industry love what they do, and they continue to stay engaged in geologic issues even after they retire. This study was just done in the United Kingdom, in Great Britain, Ireland, Wales, Scotland, where they do a survey every year of every university student in the country. And they ask them a lot of questions, including their satisfaction with their majors. And number one is geology. The geology students are the happiest with their degrees of all other majors in the college and universities in the UK. Unfortunately, we don't do a survey like that in the United States, but I think it would be something quite similar. So why are geology students so satisfied with their majors or their minors, if that's what they're doing, and they're majoring in another field? Well, first of all, is in normal times we have lots of field trips. You actually get out to do and see the things you are studying. You're not just learning about it in an abstract way, or only doing canned labs that are all prepared for you ahead of time. You have very close interaction with your professors and with grad students, and your labs are all very much hand-on, and this is largely because the class sizes are small. And this is amazing, but in spite of the need for geoscientists, because most students do not take an earth science or geology course in high school, it's not really on their radar. So we don't have as many majors as the other majors do. So therefore, our class sizes are much more comfortable, much more personal. The students get to know each other much more, and you get to work with and interact with your professor in a much more close way. We have spring and summer field camps where you get on out for extended periods of time to learn to do your field geology. We have many research opportunities. We also are very strong in that we have a lot of industry connections. A lot of our students get jobs actually working in the field while they are students, that give them an opportunity to really see what aspect of geology they really like, what size company they like working for, make relationships that often end up giving them offers of jobs just when they finish up at school. So we actually have two majors, geology and earth science, at the undergraduate level. They are quite similar. They just have different things that are required at the upper division level and different things that are left to being electives. So you could end up actually doing almost the same classes in the two different degrees, but you must do certain things in different ones of the different classes. All of our majors, both of our majors, require the introductory lecture and lab class, Planet Earth. They all require historical geology, which teaches you the history of the Earth. They all require an introduction to field class, which is where you get your first experience in going out and actually doing things and applying your knowledge in the field. We all require a year of general chemistry. We all require a year of calculus. We require a year of physics, which could be at one of two different levels, either the level that is calculus-based or the level which is not calculus-based. Then we require basic classes in crystallography and mineralogy, in igneous and metamorphic rocks, in another level up of field geology. Written communication is so important because in almost any aspect you will do in geoscience, you are going to be writing reports and you are going to be convincing people of things that they need to do or they need not to do. And so we actually have a whole course in technical writing and geologic writing. We have a course in structural geology, which is about tectonics and how rocks deform and fault and fold. We have a class in stratigraphy and sedimentology, which is about Earth's surface processes and the record we have of past oceans and rivers and deserts and things like that. And then finally, we have a capstone class. It's called summer field geology or advanced field geology, which is where you put everything together that you've done in all your time at school and you actually apply it in some large and more complex problems where you're working in areas you've never been before. Then there are other classes that you got to take like 2 out of 3 of and things like that. So geophysics, geochemistry, physical hydrology, over here in green, geomorphology. And these are classes that you have to do different ones in the earth science or the geology degree. So not only are you taking classes, but you also have the opportunity to work with professors and with graduate students in doing research. And because, as I said, our classes are small, you get to know your professors early, so you get to figure out what you might want to do and who you might want to work with. So in hydrology, studying of groundwater and surface water, Matt Becker is working in that, Professor Matt Becker. In environmental chemistry and geochemistry, we have Ben Hagedorn and Greg Hulk. In paleoclimate, mostly studying in records that were ancient lakes, but also sometimes the ocean, we have Laura Stephen Landon. In tectonics, in how the earth moves and faults and earthquakes, both modern ones, which relate to hazards, and ancient movement that related to how continents were broken apart or thrust back together